Hello Algebra 1 students, this is Mr. Wilsey, and in this video we are going to be taking down some notes about rules of exponents on this set of guided notes that I should have given you in class. Now up here make sure to put your name. This is my name, Mr. Wilsey. Now this topic, rules of exponents, we are going to breeze right through it because it is something that I think that you can pick up pretty easily and is something that you might have already seen in middle school. So we're going to not spend a whole lot of time on it. So first of all here, I have 3 squared. Okay, there's a bunch of different ways to pronounce that. You could say 3 raised to the second power, you could say 3 to the second power, or you could say 3 squared. Just like over here, that could be 4 raised to the third power, 4 to the third power, or 4 cubed. Okay, so there's a bunch of different ways of saying that expression. Now, the big thing, the big number, that 3, we call that the base. The base is the big thing. Now, the little 2 up there is what we call the exponent. So the little thing is the exponent. Sometimes it is incorrectly called the power. Like over here, if you say 3 raised to the second power, that's probably not such a good use of that word because I call the whole thing the 3 squared. 3 squared is a power of 3. So the whole thing is what I call a power. Now, of course, for middle school, I hope that you remember that 3 squared is just a shorthand way of saying 3 times 3. So 3 multiplied by itself twice, just like 4 cubed is the same thing as 4 times 4 times 4. Exponents just give us a shorthand way of indicating repeated multiplication. Now, before we go on, I want to make sure that you have these 2 mathematical words in your brain. Let me give you an example. 2x squared plus 3x minus 4. This is an expression. It's not an equation because I don't have an equal sign, but it is an expression. Now, there are 3 terms in this expression. There are 3 things that are added together. There's the 2x squared, that is a term, 3x is a term, and negative 4 is a term. Now, in each term, there might be multiple factors. So for example, if we just look at 2x squared, the 2 and the x squared are factors of that term. Similarly, if we look at the 3x, 3 and x are factors of that term. Now this vocabulary is going to become very useful for us as we continue on. Now, in this chapter, even though we don't really have books anymore, but you get the idea, we will be asked to simplify expressions. We will be asked to simplify expressions that contain an ugly combination of numbers and letters raised to different powers. I should have said exponents there, but you get the idea. Now, in a fully simplified expression, all 4 of these things are going to be true. So as you're doing problems, you can use this as a checklist. Now let me give you an example of the kinds of expressions that we're going to be looking at in this chapter. Say 12 times a squared times b to the negative 7th power times c squared. I'll divide that by 3 times a to the 4th times b to the 0 power times c to the 1st power. Let's raise this whole thing to the 2nd power. That is disgusting, but by the end of this video, you ought to be able to simplify this expression to make it look a little bit prettier. Now if we look over at our checklist here, in a fully simplified expression, each base only appears once in each term. This is a single term, but you can see that a is a base, and it appears multiple times. It appears up here, and it appears down here. So that's not true in this expression. Each base is raised only once. Well, that's not true. For example, the a is raised to the second power, and then it's raised to the second power again, out here. So that's not true. All exponents are positive and non-zero. Well, that's not true, because the b is raised to a negative exponent. The b down here is also raised to the 0 exponent. So that's not true. And the numbers raised to an exponent are simplified. Well, that's not true, because the 12 and the 3 are inside here. They're raised to the second power out here. So that's not true either. So this is about as ugly as you can possibly be. And I hope that we don't get any uglier. Alright, so now let's go through these. Let's see, these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, these 10 rules of exponents. That may seem like a lot of rules, but you don't need to memorize them. If you just learn them, then they will become second nature to you. So let's look at the first rule here. This rule you are probably familiar with. Let me show you why. Now this is the general form of the rule down here as a mathematical form. Let me read you what it means. When powers with the same base are multiplied, you add the exponents. Now let me give you an example. Let's say I wanted you to simplify x cubed times x squared. Now remember that this really means x cubed really means x times x times x. So 3x's multiplied together. And then we are multiplying that by x squared, which is 2x's multiplied together. Now if we think backwards, if we have 5x's multiplied together, that's the same thing as saying x to the 5th power. Now, a shorthand way of finding that 5 would have been to look at the 3, look at the 2, notice that we have the same bases multiplied together, so 3 plus 2 gives us 5. Now, let's look at some other examples of that. 12 to the 4th power times 12 to the 3rd power equals 12 to the 7th power. 4 plus 3 gives 7. How about this example? Negative 5. Now remember, if I want to raise a negative number to a power, to an exponent, I should use my own terminology, this means we need to wrap it in parentheses. Negative 5 to the, let's say the negative 2nd power. Let's multiply that by negative 5 to the 7th power. How would we simplify this? Well, the base is negative 5. We are multiplying these two powers. So the exponents, we add them. Negative 2 plus 7, negative 5 to the positive 5th power. One of the joys of writing in pens the whole time. Now let's look at a third example. What if I wanted you to simplify 4 times z to the 5th power times 9 times z to the negative 12th power? Now that looks pretty gross, but remember that the 4, the z to the 5th, the 9, and the z to the negative 12th, all of those are just multiplied together. And due to the commutative property of multiplication, we can rearrange the order of those factors. So let's put the 4 and the 9 up front. Those are still multiplied. Let's put the z to the 5th and the z to the negative 12th next to each other. And then now it's pretty clear to see that we can take 4 times 9, which is 36, z to the 5th times z to the negative 12th. Well, same base, multiplied together, add the exponents. 5 plus a negative 12 is negative 7. So 36 times z to the negative 7. Now, this expression is not yet completely simplified, but we haven't quite learned how to completely simplify that yet, so I'm just going to put a star next to that so we can come back to it. Alright, now that's all there is to it, to the first rule. Okay, you can see that based on what you already know about exponents, it's pretty easy to just generalize this to uglier expressions. So let's move on. Now what happens if we have two powers with the same base and we divide them? Well, we subtract the exponents, the top minus the bottom. Let's see an example of that working. What if we had, let's say, x to the 5th power, and we are dividing by x to the 2nd power? Well, in this case, remember that x to the 5th power is the same thing as x times x times x times x times x. X squared is the same thing as x times x. Now, everything up top is multiplied, everything on bottom is multiplied, so that means that if I see something on top and on bottom, I can cancel it out. So I see an x here and an x here, canceled. X here, x there, canceled. Look at what is left over. 3 x's multiplied together. So that means that this is equal to x cubed. Now, a shortcut that I could have taken to find this without writing it out completely is to say 5 minus 2 gives 3. Now let's see some more examples of that. What if I asked you to simplify 4 to the 8th power divided by 4 to the 3rd power? Well, take the top minus the bottom. 8 minus 3 is 5. 4 to the 8 minus 3rd power is equal to 4 to the 5th power. Let's try another one, except this time with letters. How about z to the 7th power divided by z to the negative 3rd power? Well, in this case, we do the same exact thing. Z to the 7 minus a negative 3. That's going to be the new exponent. Now notice that since I'm subtracting a negative number, I need to wrap the negative inside of parentheses, because this tells me to make the 7 minus a negative 3 into a 7 plus 3. Z to the 7 plus 3 is the same thing as z to the 10th power. That wasn't too bad. Now let's look at one last example. How about 3 times k to the 6th power times d to the 5th power, all divided by 6 times k times d to the negative 3rd power. Ooh, now we're getting uglier. I like it. Now, this here, exactly as we did up here, where we brought the 4 and the 9 right next to each other, we kind of separated them out from the letters. We're going to do the same exact thing here. The 3 and the 6, we're going to kind of separate them out front, but we need to make sure that they're still being divided. 3 divided by 6 times, now let's look at the k's. We have a k to the 6 and a k to the 1st power on the bottom. So this means k to the 6 minus 1. Remember, if there's no exponent here, we assume that it's 1. Now this is going to be multiplied by d to the 5 minus a negative 3. Okay, one last step here. 3 divided by 6, we can write that as a simpler fraction. That's just 1 over 2 times 6 to the, times k to the 6 minus 1 is 5th power, times d to the 5 minus a negative 3 is the same thing as 5 plus 3, which is 8. So d to the 8th power. So that was not too bad, I hope. It looks ugly, but for most of these, you can just follow them step by step. There's really not any complicated thinking going on here. It's just being careful and knowing your rules. So far, we've only seen 2 rules, but already the expressions can get pretty ugly. Alright, now let's move on to rule number 3. Let's read what this says. When a power is raised to another power, you multiply the exponents. In reality, I should say, when a power is raised to another exponent, you multiply the exponents. Now, let's give an example of that. Let's say we have x cubed, and we want to square that. The way that we write it is, we wrap this guy in parentheses, have a square out here. So x cubed squared is what we're trying to simplify. Now remember that anything squared means that we take what's inside the parentheses and we just multiply it by itself twice. So x cubed squared is the same thing as x cubed times x cubed. Now here, x cubed is the same thing as x times x times x. And again, we're multiplying that by x times x times x. We have 6 x's multiplied together. So the way to simplify that is x to the 6th power. Now, based on what we have up here written out, we could have noticed a shortcut. 3 times 2 equals 6. So that's how we find the new exponent of our simplified expression. So let's see an example of that. Let's say I have n to the 4th power, and let's say I want to raise that to a new exponent to the 7th power. All I have to do here is multiply 4 times 7, which is 28. So that is the new exponent of n. Now let's see a little bit more of a complicated expression. How about x to the negative 3rd power? Let's say I want to raise that to the negative 4th power. Let's say I want to multiply all of this by y to the negative 2nd power, but I'm going to raise this guy to the 8th power. Mr. Wilson, you're getting crazy. I know, I've been crazy. Not getting there. Been there. Let's just starting to show. All right. This means that we take the two exponents and multiply them together. So negative 3 times negative 4 is positive 12. So x to the positive 12th power is going to multiply y. And what's going to be the exponent on y? Well, negative 2 times 8 is negative 16. Now, just like on the last page, this is not completely simplified yet because we have a negative exponent. We don't like those, and I'll teach you soon a way to get rid of negative exponents. So I'm going to put a star here so we can come back to this. We can revisit it. So that is all there is to it, to rule number 3. Now let's look at rule number 4. Exponents can pass through parentheses if the stuff inside is multiplied or divided. Now here's the general forms over here. Now let me give you some concrete examples of that. Example number 1. Let's say I wanted you to simplify 4 over 3, but I'm telling you to square it. Well, you might be tempted to bring the 2 inside of the parentheses and attach it to the 4, but you can do that as long as you also attach it to the 3. Okay? So 4 squared divided by 3 squared. Here, 4 squared, of course, is 16. 3 squared is 9. So that could be a way to simplify that expression there. So the exponent can pass inside of parentheses if the stuff inside is divided, like we showed here. What if it's multiplied? Let's say we have k squared times d inside of parentheses. Let's raise this to the 4th power. Well, the exponent can pass inside of the parentheses as long as we attach it to every factor inside of here. So k squared to the 4th power times d to the 4th power. This is equal to k to the 8th power times d to the 4th power. Now let's look at another example that gets a little bit more difficult, not terribly so though. How about a to the 4th power divided by b to the 2nd power? Let's raise all of that to the 3rd power. Well, here, this is the same thing as a to the 4th power in parentheses to the 3rd power, and then I'm going to take the b squared and raise it to the 3rd power separately, b squared to the 3rd power. Now here, I can use the rule that we just learned up here again. A to the 4th power to the 3rd power is a to the 12th power. You just multiply the two exponents. Same thing down here, multiply the exponents, b to the 6th power. And that's as far as we can go on that one. One more example of that. What if we had, let's say, x squared times y divided by z to the 3rd power, and we're raising all of this to the 3rd power. This is equal to, I'm not even going to make this intermediate step. I'm just going to say the 3 can go to the x squared and to the y and to the z cubed. So x to the 6th power, so I'm multiplying these, times y to the 3rd power, divided by z to the 9th power, multiplying the 3 and the 3. Now let's take a look at rule number 5. Rule number 5 tells us what we cannot do. Up here, this is what we can do. This is what we cannot do. What this is saying is that you cannot pass the exponent through the parentheses if stuff inside is added or subtracted. So let me give you an example of that. 4 plus 5 inside of parentheses raised to the 2nd power. Now, analogous to what we did up here, you might you might be tempted to bring the 2 inside of the parentheses and attach it to the 4 and to the 3. Down here, you might be tempted to bring the 2 inside the parentheses, attach it to the 4 and to the 5. So let's make an equal sign with a question mark on top of it. Is this equal to 4 squared plus 5 squared? Well, let's see. Let's look at the left side first of all. 4 plus 5 is just 9 squared. 9 squared is 81. Now let's see if that is equal to the right side. 4 squared is 16, plus 5 squared is 25. 16 plus 25 is 41. Last time I checked, 81 is not equal to 41. So none of these expressions are equal. So the lesson we learned here is that you cannot pass the exponent inside of parentheses if the stuff inside is added. Same thing is true if you subtract them. You cannot do that. And later on in this course, we will find out what you can do in this case. Alright, let's move on to rule number 6. We are cruising along.